Good morning, students. Myself is Dr. Santosh Kumar Chaudhary, reader in chemistry. Last in class number 3, in the chapter of aldehyde, ketone, carboxylic acid, we discussed about some method of preparation of aldehyde ketone. That is, aldehyde ketone can be prepared from alkyne and alkene. And we discussed some characteristics, some physical characteristics and some chemical characteristics. And in physical characteristics, formaldehyde is a gas and it is soluble in water, and 40% solution of formaldehyde is known as formalin. Okay, and we have discussed some chemical characteristics. The chemical characteristics of aldehyde ketone are almost same because both are containing the carbonyl group. Some other characteristics aldehyde differ from the ketone we discussed later. And the carbonyl compound or carbonyl group possesses carbon-oxygen double bond. And in carbonyl group, the oxygen is more electronegativity than carbon. That's why the carbon atom possesses partially positive charge and oxygen atom possesses partially positive charge. And the carbon oxygen possesses double bond. That's why the carbonyl group compound, that is our aldehyde ketone, shows the nucleophilic addition reaction. That is, the nucleophile is initiated. That is, the reaction initiated by a nucleophile. That means during the reaction, the nucleophile will attack to the positively charged carbon atom of the carbonyl group to form an anion intermediate. That means the oxygen atom intermediate in which the oxygen atom carries the negative charge. After the formation of this intermediate, this is attacked by the electrophile E+, so to form the corresponding addition compound. Okay. So the reactivity order of aldehyde ketones that depends upon the positive charge possessed by the carbon atom of the carbonyl group. That means the carbonyl group in which the carbon atom in the carbonyl group in which the carbon atom possesses more electropositive charge, that is more reactive, means that will attack the nucleophile so easily. In that regard, the formaldehyde is just more reactive or strongest reactive towards nucleophilic addition reaction than any other aldehyde, then the benzaldehyde, then the ketone. It is observed that when the ketone, the symmetrical ketone or unsymmetric ketone possesses the bulky groups, then the reactivity of the ketone decreases, almost not reactive. For example, benzophenone, that is C6H5CO, C6 is called benzophenone. You see, this benzophenone containing two bulky phenyl group or electron donating. That's why this compound is least reactive towards the nucleophilic addition reaction. Okay, students, today we will discuss the detail about the addition reaction of aldehyde and ketone, and the aldehyde ketone, that is the carbonyl group compound, shows the nucleophilic addition reaction. Today we will discuss the addition reaction of aldehyde and ketone. Second, you can discuss the addition and elimination reaction with derivative of ammonia. Third, we will discuss the reduction, and fourth, we will discuss the oxidation. So, first we'll discuss about the addition reaction of aldehyde and ketone. That means aldehyde ketone addition reaction is due to the carbonyl group present in the aldehyde and ketone. You know, the carbonyl group, this is your carbonyl group, it undergoes the nucleophilic addition reaction. That means the carbonyl group, this is your addendum, this is positive part, electrophilic part, this is nucleophilic part, and this bonds break here. The nucleophilic part come to the carbon side, and electrophilic part goes to the oxygen side, because carbon is positively charged, oxygen is negatively charged, to form the corresponding addition compound. And this is your addition compound, and this is what racemic in nature. As a reaction, the product mixture, the product contains the mixture of equal amount of D form and L form. That's why it's a racemic product. Okay, first you discuss one by one. One, addition of HCN, hydrogen cyanide or hydrocyanic acid. The carbonyl compound, that is aldehyde and ketone, can add a molecule of HCN at pH more than 7. In HCN, this is your positive part, this part is the negative part. During the addition reaction, this bond break here. This side is CN, this side is H, to form COH, CN. This is called cyanohydrin. So, during the reaction, we maintain a pH is more than 7, means slightly alkaline in nature. Why will take slight alkaline in nature? Because HCN is weak acid. It dissociates feebly, means very less. But in presence of a base, means pH more than 7, the dissociation is more and produce Cn minus. That's why during addition of the HCN, the pH of the medium slightly alkaline in nature to increase the dissociation. So now come to how can the HCN react with cyanohydrin. Suppose you take the formaldehyde. In formaldehyde, this is your carbonyl group. You are adding what? HCN at pH greater than 7 or slightly basic in nature, or maybe pH suppose equal to 8. This is added to here, it forms HCOH CNH, that is this is your formaldehyde cyanohydrin. Suppose you take acetaldehyde, CH3CHO. This is your acetaldehyde that react with HCN at pH 8. It gives you CH3CHOHCN. This is a acetaldehyde cyanohydrate. Similarly, if you take acetone, suppose you take acetone. So this acetone, that is CH3, C double bond O, CH3, this is your acetone, Canada molecular HCN at pH 8, slightly alkaline medium. The HCN added across this carbonyl compound to form CH3C, CH3OH, CN. This is called acetone cyanohydrate. Acetone cyanohydrate. Okay, what about the use of this cyanohydrate compound? Suppose you take this is your carbonyl group present in an aldehyde ketone. It add an RDA. It gives you addition product. That this side OH, this side is CN. Now the cyanohydrate compound. This is on reduction. This CN group, C triple bond N, the CN group in C triple bond N is reduced to CH2 NH2 group. That is, it gives you COH CH2 NH2. This is called one type of hydroxyamine. If this cyanohydrate compound on hydrolysis, you know this CN group is hydrolyzed to what? COH. So this CN group hydrolysis to form a hydroxy group, that is, it is a compound that is alpha hydroxy acid, just like to a lactic acid. Okay, students, suppose I will take acetaldehyde. That is, you take acetaldehyde, CH3, C double bond OH, this is CH3CHO, this is called acetaldehyde added with HCN at pH 8, it forms acetaldehyde cyanohydrate. This is on hydrolysis. What will happen? This group is hydrolysis to give what? It gives you CH3 CH, CH3 CH, OH, COOH. This is your lactic acid. This is what? Lactic acid. Okay, students. Suppose if you take benzaldehyde, C6H5, C double bond OH, When added with HCN at pH 8, it gives you C6H5 CHCNOH. This is called benzaldehyde cyanohydrin. This is on hydrolysis. This group is hydrolyzed, that is CA6H5 CHOH COH. This is called a mandelic acid. That is, we can say alpha phenyl hydroxyethanoic acid or acetic acid, or 2-phenyl 2-hydroxyethanoic acid. Okay, student, these are the reaction of carbonyl group compound with HCN. That means the carbonyl group compound aldehyde or ketone can be converted into converted into alpha hydroxy carboxylic acid or alpha hydroxy amines. And during this reaction, one more carbon atom increases, that is the ascending order. Now come to the addition of sodium bisulfite compound. Second one is addition of sodium bisulfite. This is called sodium bisulfite compound. When the carbonyl group compound aldehyde and ketone treated with sodium bisulfite, the saturated solution sodium bisulfite, it gives the addition compound, and this is your carbonyl group, this is your sodium bisulfite, and you see this part is positive part, this part is your negative part. So Na plus, HSO3 minus. So this will added across the pi bond. This became CONA, because Na this side, Na this side is the SO3H. So this side is SO3H. After forming this one, the transfer of proton, the proton transformation COH SO3 Na. This is your sodium bisulfite compound. Corresponding aldehyde ketone, and this sodium bisulfite, it is a white precipitate. When it treated with this white precipitate, treated dilute HCl, it gives back to corresponding aldehyde and ketone. That means on acidification, this compound gives OH, and this became OH. And this lost molecule of water, this gives you carbonyl group. This gives you original carbonyl group compound. So any aldehyde ketone when treated with saturated solution of sodium bisulfite, they give the white precipitate of corresponding sodium bisulfite compound. And this sodium bisulfite compound is treated with, which is white precipitate, is treated with HCl, it will give back to original carbonyl group compound. That's why the sodium bisulfite compound, it is used to identification and separation of carbonyl group compounds. Means this method can use to identification whether the carbon group compound present or not, and you can separate from others, because when the mixture is treated with sodium bisulfate compound, all the carbonyl group compound react with the sodium bisulfate compound white precipitate, and then it is filtered, the residue white precipitate, it is a dilute acid, give back to corresponding aldehyde ketone. Mind it, this reaction shown by not all the ketones, shown by only acetone. When the ketone contain a very bulky group, means the reactivity of ketone is decreases. When the reactivity decreases, because it is one of the weaker reagent. That's why the bulkier ketone does not react with sodium bisulfite compound. Okay, students, let us take one by one. Suppose you take the formaldehyde, you take the acetaldehyde, you take the acetone. Suppose this is your formaldehyde, sodium bisulfite. So this will arrange going to gives you direct this step, that is proton transfer. This is called what? Proton transfer, and this is sodium formaldehyde. Sodium bisulfite compound. This is a white precipitate. Similarly, you can take acetaldehyde, CS3, C11OH. This is your acetaldehyde, that is sodium bisulfite compound. Can you write what is the product here? The product is CS3, COH, SO3, NaH. This is called acetaldehyde, sodium bisulfite compound. Okay, students, if you take acetone, you will get almost same product, same type of product. Suppose you take acetone, plus sodium bisulfite compound, that gives you acetone sodium bisulfite compound. Okay, and to detect the carbonyl compound, we must be, you may use the aqueous solution of saturated aqueous solution of sodium bisulfite compound. Suppose a mixture containing ethanol and ethanol. Suppose a mixture containing, that is ethanol plus ethanol. How can you separate these? To separate this, This will be treated with saturated solution of sodium bisulfite to give the white precipitate of acetaldehyde, sodium bisulfite, compound of ethanol. Then you filter it. If you filter, it gives you residue of the precipitate, and this is your filtrate, and this filtrate is your what? Ethanol. Now the residue treated with dilute HCl, it gives the solution of ethanol. That's why sodium bisulfite compound is used for the identification and separation of the carbonyl group compounds. That is particularly aldehyde and ketone. Okay, student, this is the addition reaction of sodium bisulfite. Next come to addition of Grignard reagent. Addition of Grignard reagent. You know, the addition reaction of Grignard reagent we will already discuss. That is your RMGX in your alcohol chapter. That method of preparation of alcohol from aldehyde and ketone. You know, when you take the formaldehyde, react with Grignard reagent, it forms addition compound OMGXR. This is unstable, and this is on hydrolysis. What happens? Acidic hydrolysis. It gives a what alcohol? Primary alcohol. That is, this group which get converted into what? Primary alkali group CH2OH. Similarly, if you take any other aldehyde, that R dash CHO plus RMGX, which upon acidic hydrolysis it gives a secondary alcohol R dash CHOH. This is your secondary alcohol. Similarly, any ketone R dash CO R double dash RMGX, it forms addition compound. Your addition compound on acidic hydrolysis, it gives a tertiary alcohol. Okay, student, this reaction we will already discuss in the alcohol chapter, the method of preparation of primary, secondary and tertiary alcohol from Grignard reagent. We will not discuss anymore this much. Let's come to the addition of ammonia. So, what is ammonia? NH3. The ammonia are to aldehyde and ketone to give different products. Formaldehyde gives one type of compound, aldehyde gives another compound, ketone gives another type of compound. We will discuss the addition of ammonia with formaldehyde, with acetaldehyde and acetone. First come to the reaction with formaldehyde. So, one molecule, that is formaldehyde, there are 6 molecules of formaldehyde react with 4 molecules of ammonia. It form a cyclic compound. The cyclic compound is your CH2 whole 6N4. This is called hexamethylene tetraamine plus 6H2. And this hexamethylene tetraamine is a cyclic compound. It is known as a medicine urotropin. And this medicine, that is urotropin, is a commercial name of hexamethylene tetraamine, and this urotropin used as a medicine, that is antiseptic, that is urinary infection. And the structure of urotropin is a cyclic compound. So this is your CH2 N, you see CH2. So N is nitrogen, it is a 3 valency, that is CH2, 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 and each CH2 group has 2 valency. One, this is another one, N, another one, N. You can draw the structure of urotropin. The structure of urotropin is N, CH2, 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 again N, 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 and this is CH2, this is CH2, and these two are CH2. Okay, this is the structure of urotropin, that is 1, 2, 3, 4, 5, 6, that is hexamethylene, 1, 2, 3, 4, this is your tetraamine. And this structure of what? Urotropin. That is what happens when formaldehyde treated with ammonia solution. When formaldehyde treated with ammonia solution to form a cyclic compound of hexamethylene tetraamine, which is known as urotropin. And this is the structure of urotropin. You see the amine cyclic coordinate 1, 2, 3, and total is 4. Urotropin containing 4 number of cyclic. And this urotropin is also used to its nitro derivative as an explosion. Okay. Next come to the reaction with acetaldehyde and ammonia react with acetaldehyde, that is your ammonia react with acetaldehyde, it get added here to form CH3COH NH2, and this is called acetaldehyde ammonia compound. Can you name this? You can name this. This is your 1, 2, 1 amine ethanol. 1 amine ethanol. 1, 2, 1 amine. There are 2 more components of ethanol. 1 amine ethanol. Okay. Next come to the reaction of ammonia with acetone. So CH3 C double bond O CH3, this is your acetone, can react with ammonia. It can add a molecular ammonia to carbonyl group, that is CH3 C CH3 OH NH2. And this addition product, that is acetone ammonia compound, can further react with another molecule of acetone, that is CH3 CO CH3, and this get lost molecular water. So this give a product like this is your CH3 C CH3 CH3 C CH3 NH2 bond, but CH2 CO CH3. This is called diacetone ammonia compound. What is this called? Diacetone ammonia compound. And the IPAC name, what is the IPAC name? 1, 2, 3, 4, 5, 4 amino, 4 methyl, pentane 2 OH. Okay, this is the reaction of ammonia with acetone, that is 3 different compounds, that is acetaldehyde, formaldehyde and acetone, and react with ammonia, it gives 3 different products. In case of formaldehyde, it gives a cyclic compound that is called hexamethylene tetramine, that is called urotropine. In case of acetaldehyde, it gives you acetaldehyde ammonia compound, but in case of acetone, it gives finally a diacetone ammonia. Okay students, next come to the reaction with, these are all about your addition reaction of aldehyde and ketone, and aldehyde ketone get added with HCN, sodium bisulfite, Grignard reagent and ammonia. Now come to second part, the addition and elimination reaction. The addition elimination reaction generally shown by the derivative of ammonia. What is this derivative of ammonia? What is ammonia? That is NH3 is called ammonia. When the hydrogen atom replaced by a group G, G means I will say, then it gives you GNH2. This is called derivative of ammonia. And the derivative of ammonia are HO and H2. When G is equal to HO, G is equal to HO, this is called hydroxyl amine. So hydroxylamine is the derivative of ammonia, in which the hydrogen atom of ammonia molecule is replaced by the OH. Second, if this group is replaced C6H5 NH2, this is called phenyl hydrazine. if the phenyl group means C6H5 group, that is a benzene ring, this is your C6H5 group is substituted by a nitro group. This is a NO2 group. This is another NO2 group. This is NH, NH2. This is called 2,4 dinitro phenyl hydrazine, shortly 2,4 DNP. These are another derivative of ammonia. And another derivative of ammonia, that the derivative of urea. Urea is what? NH2CO, NH2 is called urea, and the H is replaced by the NH2 group, and this is called carbazite. What is called? It is called semi-carbazite. You mark the derivative, these are the derivative of hydroxylamine, phenylhydrazine, 2,4-DNP, semi-carbazite. These are all are the derivative of ammonia, and each derivative of ammonia must be contain a what group? NH2 group. And this NH2 group is added across the carbon group of the double bond. Okay, how the derivative of ammonia react with the carbonyl group compounds. So, are you clear what is derivative of ammonia? And the derivative of ammonia is possesses a NH2 group. And now come to the carbonyl group compound. This is your carbonyl group compound are present in your aldehyde ketone. This carbonyl group compound react with derivative of ammonia. That means this is added here. To this side you add what group? This side H, this side is NHG. You see GNH2. When you add this, it gives you GCOH NHG. And this addition product is unstable. You see, this is addition first. First your addition. And the addition product is unstable because the carbon atom loaded with the OH group as well as NH group. You see, this is bonded carbon bond oxygen bonded with nitrogen. When the carbon bonded with two more electronegative group that became unstable, immediately get lost molecular water. That's called elimination. It eliminated molecular water. That's why the reaction is said to be addition elimination. Addition of the derivative of ammonia, eliminate molecular water, and the result to form C. This is going to come here what? Double bond NG. This is the addition elimination product. Okay, students. So, now come to the how the addition elimination reaction is shown by formaldehyde. So first we come to reaction with hydroxyl amine. What is this hydroxyl amine? HO NHO. This hydroxyl amine. The carbonyl group compound that react with hydroxyl amine, the pH should be maintained. That is, the pH should be 4 to 5. That means slightly acidic in nature. Not more acidic. Slightly acidic in nature, not more basic. Because ammonia will derivative deactivate. So it gives you what? COH NH2, and this compound is known as oxime. Oxime. This compound is known as what? Oxime. Okay, you can write if you take the formaldehyde plus hydroxylamine at pH 4 to 5, and write the product. The product is your formaldehyde oxime. Can you write the product? What is the product? CHOH NH2. That is CH2OH NH2. That is called formaldehyde oxime. Similarly, if you take acetaldehyde, and with hydroxylamine at pH 4 to 5, what product? What product it gives? It gives you acetaldehyde oxime. Similarly, you can take acetone that react with hydroxylamine at pH 4 to 5 to write the product. That's called acetone acetone oxime. Acetone oxime. Okay, it is the reaction of derivative ammonia with formaldehyde, acetaldehyde, and acetone. Then you write the reaction with derivative of ammonia, that is another half the phenyl hydrazine. What is this phenyl hydrazine? C6H5 NH NH2. You see this containing a NH2 group, and this phenyl hydrazine treated with any carbonyl group compound at pH 4 to 5, it gives addition compound, that is OH NH C6H5, get lost molecule of water. This is your unstable. This gives you C double bond N C6H5. This is called phenyl hydrazine. If you take acetaldehyde, that you can say acetaldehyde phenyl hydrazine. Okay, students, I will make some mistake there. That is C double bond O and 2H OH. This gives you C double bond N OH. This is called oxygen. This is called what? Oxygen. Okay, students. We will discuss this much today. We will discuss in next class, and we will discuss about the addition reaction of aldehyde ketone and the aldehyde ketone